36 and 2 would work if it was the square root of 72. Cubed root of 72. What perfect cube goes into 72? 8. So that's going to be the cubed root of 8 times the cubed root of 9. And the cubed root of 8 is 2. So 10 times 2 is 20. Cubed root 9. So easy?
Yeah.
Good. What's going to happen in number 3, Mitch?
You're going to multiply 8 times 4. And you can get 32 radical 7.
32 radical 7. So if one doesn't have a radical, you just keep the radical that's there. Same thing's going to be true if one did not have a coefficient. You would just keep the coefficient that's there, right? Because technically you're multiplying it by 1 for root 1, I guess you could claim. And that one doesn't get simplified, so we're all good there. And then distributing is still going to be a thing. So 8 root 3 times 5 root 6. What do you think that is, Jake W?
40 radical 18.
40 radical 18. And the next distribution, Jake O.
16 radical 9.
16 radical 9. Good. So now, how am I going to break down root 18? What do you think, Tori? What's a...
16.
we need a perfect square that goes into 18.
9.
Root 9, root 2. Good. Which will make that overall term... What, Gracie? What's the square root of 9? 3 times 40. 120 root 2. Good. Plus, how do we break down root 9, Val? Nope. Maybe it was a trick question. You don't actually break down 9, right? Because it already is a perfect square. So we would just really circle it, and now when we take the square root of it, the answer is 3 times 16 is 48.
I do just leave it like that.
Yeah, why did you add them together?
Yeah, I almost did.
Because they're, and I actually was going to address that anyway. You don't combine them because they're not like radicals, right? If it was 120 root 2 plus 48 root 2, then they're like radicals. Then you combine. But they're not like terms. Are we good with that? Number 5, when you initially multiply these, Maggie, what do you get?
18x to the 4th.
Good. Root 18x to the 4th. Mike, how do you break down 18?
9 2.
Root 9, root 2. How do you break down x to the 4th? Samantha?
X squared. And x squared. Or 3.
It's a square root, so you need that to be divisible by 2. It already is, right? So then, no, then the answer is don't break it down. Listen, when I say break down, I'm talking about splitting it up into blank times blank. When I go from this step to the next step, that's me kind of actually simplifying. Just so the language, I think that you would have done the right thing on your own. I think that maybe my questions are a little confusing. So I'm all about how do I break things down first. Then I worry about actually applying the square roots. So we have 3x squared and root 2. So just so when I say things, you know what I'm referring to. I believe that Samantha would have done that right without me talking to her, actually. Number 6, when I initially multiply, see how they're both 4th roots? Okay? I wouldn't be able to multiply them if they weren't. Brock, what does that become initially?
48x to the 3rd.
48x to the 3rd. Just like that?
Oh no, with a 2, it's 2 in front and then bracket.
The fourth root. So he meant 2 times the fourth root of 48x to the third. You happy with that? Is that what you wanted me to write?
Yes.
Okay. I need the rest of you to comment on that. Should have been x to the 6, you see? X to the third times x to the third becomes x to the 6. Good catch, everybody. And then, now I break down. So I need to break down 48. I'm looking for the fourth. I'm looking for the fourth root. So what is the perfect 4 power that goes into 48? 16. 16 times 3. For those of you who don't know where 16 came from, let's listen to how we come up with our perfect 4s again. Okay? And this is really one time in math where I still use my fingers to count, because I'm going to come up with the smallest perfect 4th power, which is taking 2 and multiplying it by itself 4 times. So 2 times 2 is, times 2 is, times 2 is, so there is your perfect 4th power, 16, right? So the fourth root of 16 is now 2, okay? How am I going to break up x to the 6th? Josh? Well, I need this number to be divisible by 4. Is it already divisible by 4? No. So what's the smallest number under 6 that is divisible by 4? 4. So I need it to be x to the 4th, and times x to the what would be a good replacement? What power would appropriately replace the 6? 2. Very good. So the fourth root of 16 is a 2, times the 2 that's already there is 4. That takes care of those. The fourth root of x to the 4th is just x. And then my 3 and my x squared are stuck under the radical. Good? Now, did we do this one yesterday? What's that? Yeah, I think it was. It was the exact same thing, remember? Because what would we have taken the cubed root of that would have given us a 2? 8, so we put the 8 back underneath. What would the m have, what would we take the cubed root of that would have caused us to take an m out in front? Well, no, m cubed. Yeah, and then and then what would the n have had to have been for us to take out an n squared? N to the 6th. And then when you simplify all that, you get 40, m to the 4th, n to the 8th. And that's what we were looking for. So thinking through that backwards. Good? Okay. Did we do this one yesterday too? You want to go over it again? Okay, we'll go over it again. So I don't remember if I did this yesterday, but I'm going to split it up into 4 different problems. The nth root of 3 times the nth root of 2 to the n times the nth root of x to the 2n times the nth root of y to the n plus 3. Okay, so term by term, the nth root of 3, we got nothing, right? There's nothing I can do with the nth root of 3, so that's going to stay. The nth root of 2 to the nth power is just 2, right? So if it was the 4th root of 2 to the 4th, or if it was the 5th root of 2 to the 5th, those all just cancel. So if it's n and n, it just cancels. So this is going to be, so we've got the nth root of 3, nothing can happen. This one is just 2. Now with our variables, we want our exponent to be divisible by the root. Is 2n divisible by n? Yes, right? And so if we want to actually simplify that, we do the division. What is 2n divided by n? Just 2, so that's just x squared. Right? And the last one, we want, again, the exponent to be divisible by n. Is n plus 3 divisible by n? Sort of depends on what n is, but probably not, right? There's only a couple numbers that would work for. Like, for example, let's pretend n was 5. It would be the 5th root of y to the 5 plus 3, right? Which would be the 5th root of y to the 8th, which you would break down y to the 8th how? Right, you would break it up into y to the 5th and y to the 3rd anyway, which would be y, 5th root of y to the 3rd. Yes? If, let's say, it was this n was 7, if it was the 7th root of y to the 7 plus 3, you would really do the same thing, right? Initially it would become y to the 10th, but you would then break it up into the 7th root of y to the 7 times the 7th root of y to the 3rd. Yes? So this one really gets broken down into the nth root of y to the n times the nth root of y to the 3rd. Because our exponent rules say that y to the nth times y to the 3rd, those would get added to be n plus 3. Do we see that? Right? When you multiply common bases, you add the exponents. And so when we break it down like that, this is always going to give us y, and then we're probably left with the nth term of y to the 3rd. So the 2x squared y goes out in front. And then it's the nth root of 3y cubed. So I think this part's the most challenging part to wrap your head around, right? Wouldn't you say? What if I gave you this? The nth root of x to the n plus 5. Isn't that the same thing as the nth root of x times the nth root of x to the 5th? That's an x to the n. These two would multiply to become the nth root of x to the n times x to the 5 becomes x to the n plus 5. See that? And then this will always be x times the nth root of x to the 5th. It's definitely tricky when you have such an abstract root, right? Everything's much easier if you have a concrete root. You're taking the 3rd root with a 4th root. If it's concrete, that's fine. If it's abstract like that, it makes it a heck of a lot tougher to think about, which is why I think it would be helpful if you're ever in a circumstance like this, and it can happen in any type of problem, where something is too abstract that you can't really wrap your head around it, make up a number for n and just kind of explore what happens. And if we make up a different number for n, we would explore what happens. This would become the 7th root of y to the 10th. Y to the 10th we would break down into y to the 7th times y to the 3rd, right? And then you'd get y times the 7th root of y to the 3rd. So regardless, you're getting y times the nth root of y to the 3rd. Does that make sense? Good? Kelly, how you feeling about this? Like I said yesterday, I think those are kind of like bonusy type questions in my opinion, but also like I said, the first Algebra 2 Regents I looked at looked like all bonuses in my opinion. So that's what we're up against. Alright, so getting back to addition and subtraction. Do me a favor. Change this number to 48. So 2 times the 4th root of 48. Because I want something to happen at the end that we can learn from. So, adding terms, what do we need? Same number, another radical. We need like terms. Usually we simplify first, but actually, because these are already like terms, we could simplify them right from the start. So let's do that. 4 times the 6th root of 3 plus 2 times the 4th root of root 48. And what's my last term going to be, Lucy, when I combine these? Sixth root of. Right, but I don't, did you multiply these to get 6? I'm not doing multiplication. I'm doing negative 3 of these minus 2 more of these. Negative 3 minus 2 is negative 5. So now let's simplify. And on the first term, obviously, we can't simplify. So 4 times the 6th root of 3 is there to stay. I'm looking for the 4th root. So what's a perfect 4th power that goes into 48? 16. So I'm going to break that down into 2 times the 4th root of 16 times the 4th root of 3. And the 4th root of 16 is 2. 2 times 2 is 4. So 4th root of 3. And on the last one, I'm looking for a perfect power of 6. Okay, here I go counting on my fingers again. I'm going to try and see what 2 to the 6th power is first. 2 times 2 is? 4 times 2 is? Times 2 is? Times 2 is? Times 2 is? 64. So 64 has a 6th root. The 6th root of 64 is 2. Just a side note. Does 64 go into 192 by any chance?
Yeah.
Good. It does. So we're going to break down 192 into the 6th root of 64 times the 6th root of, how many times did it go in? 3. And the 6th root of 64 we just said was 2. 5 times 2 is 10. So negative 10. 6th root of 3. Now, can we combine anything? What, Brayden? This 4 or this 4? Why this one, why not that one? Because they have different roots. Very good. So I made them all 3s. That's why we changed that number. But these two are the 6th root of 3. So these two can be combined. That middle one cannot be. So your final answer, 4 of these minus 10 of these, is negative 6. 6 roots of 3. Plus, and we just have to keep the 4th root of 3 a separate term. Admit it, you love radicals. They're a little bit crazy, huh? All right, last one. Can we combine anything right off the bat? What do you think, Kelly? No? Look again, my dear. There's some like terms in there. What are they? Right. Those are like terms right off the bat. So 2 and 3 makes 5 of those. And then the rest is the same. And then simplify. Can we simplify any of those? Which one? The 6th root of 384. Hopefully 64 goes into it. How many times? So I'm going to break that up into 64 times 6. So the last term, the 6th root of 64 is 2. Times the negative 3 is negative 6. 6th root of 6. We have 5 times the cubed root of 6 minus the 6th root of 6. So, my eyes are all foggy. It's like a lot. Negative 7. Negative 1 of these minus 6 more of these. This is not combinable either. So it's 5 times the cubed root of 6 and then minus 7 times the 6th root of 6. Negative 1, negative 6 combines to negative 7. Whew! How do you feel about that?
Is this not our homework?
Hmm?
Is this not our homework?
This kind?
Yeah.
What was on your homework last night, was it not? Yeah. There, well, so yeah, I kind of took addition and subtraction, I upped them a little bit. You don't have the 6 roots, they're all cubed roots on your homework. 6 roots is stretch, I don't think you'd maybe really ever see that. But, if you do see roots that you're not familiar with, figure out what they are, right? Just like that counting method that I used on my fingers, or type it into your calculator. Your homework. You guys have a quiz coming up on Friday on radical stuff. Plus, take a look at your spiral questions because you know I love to throw a couple of those on your quizzes. Make sure you're learning from your spirals as you should be. That's my way of knowing to actually do those.
They're like required.
Right now. Do you want to take a quiz right now? Like the vocab quiz? We have a few minutes.